In your notes, we generalized the formula we had for the nth partial sum for 1 over 2 to the n. For the geometric series, the sum from n equals 1 to infinity of a times r to the n minus 1, where a is some constant and r is also some number. This is convergent if the absolute value of r is less than 1, and it's divergent otherwise. And we actually have a formula for the sum in this case for this series. And the sum from 1 to infinity of a times r to the n minus 1, if the absolute value of r is less than 1, is a over 1 minus r. And of course, this ties in with what we had before when r was equal to 1 over 2. Well, let's try to use this formula. Sometimes we have to work a little to use the formula. Either the sum starts at somewhere other than 1, or it's not obvious what the a and the r should be. So suppose we want to find the sum of the series, the sum from 1 to infinity of minus 1 to the n times 10 over 4 to the n minus 1. This is a geometric series, and we have to figure out what the a and the r are in order to use our formula. The best way is to expand our series, write out the first few terms, and see what the pattern is. So the first term here is when n is 1, and we get minus 10. When we plug in n equals 2, we get plus 10 over 4. N equals 3, we get minus 10 over 16, etc., etc. We have to identify the values of a and r by comparing to the expanded version of the series we're working with above. A is always the first term. So in this case, a is minus 10. And notice the second term is a times r. So the second term divided by the first should give us the value of r. So we have r is equal to 10 over 4 divided by minus 10, which is minus 1 over 4. And now, just to be sure that our geometric series is in the right form, we should calculate a times r to the n minus 1 and make sure it agrees with the formula given in the series. And sure enough, for our a equals minus 10 and r equals minus 1 over 4, a times r to the n minus 1 is minus 1 to the n times 10 over 4 to the n minus 1, which is the formula we're given for the nth term of the series. Now we can plug things into our formula. So we have this sum is a over 1 minus r, which is minus 10 over 1 minus 1 over 4. And this is minus 10 over 5 over 4, which is minus 8. So the sum of our series in this case is minus 8, and our series converges. Well, here's another application. The sum from 1 to infinity of 2 over 3 to the n. Again, as I mentioned before, the best way to figure out what the a and the r are in this geometric series is to expand the series. When n is 1, we have 2 over 3. When n is 2, our second term is 2 over 9. When n is 3, the third term is 2 over 27, etc., etc. And remember, a should be the first term, and a times r should be the second term. So in this case, a is 2 over 3. R should be the second term divided by the first, which is 2 over 9 over 2 over 3, and this is 1/3. So again, just to be sure that our numbers are correct, we should check that a times r to the n minus 1 is the nth term of our series, that the formula agrees with what we're given. So when we calculate a times r to the n minus 1, we get 2 over 3 times 1 over 3 to the n minus 1, which is 2 over 3 to the n, which is indeed the formula in the given series for the nth term. Now that we know that our a and our r are correct, we can apply our formula. The sum of the series is a over 1 minus r, which is 2 over 3 over 1 minus 1 over 3, which is 2 over 3 over 2 over 3, which is 1. This series converges, which we know because the absolute value of r is less than 1, but in fact we can say what the sum is it sums to 1.